Okay, this video is going to review SLTs 1 and 2 in our unit 4 modeling unit. So go ahead and turn to page 18 in your packet. Examine the pre-image, the parent function, and think about what transformations occurred to create images 1, 2, and 3. You should pause the video now to work on this. Okay, when we look at the pre-image, we notice it's a parabola, it's x squared. And so when I look at image 1, I notice that the y values are the same. So this is not a transformation on y, but I do notice that all these x values have been decreased by 3. So what has happened, because it's been decreased by 3, is that it's actually moved 1, 2, 3 units to the left. Because it's been moved to the left 3, we're going from x, y to x minus 3y. But the function notation is going to be x plus 3 squared. Now remember, that means if I plug in -5, if I substitute -5 into my function, I need to get 4. And sure enough, -5 plus 3 is -2, and squared gives us 4. For image 2, I notice the x values are unchanged, but there is a change in the y values. Now, what's important to notice is that this 0 value is still 0, and that tells me that there's some kind of dilation going on. So 1 to -3, 4 to -12. This is a dilation of 3 and also a reflection over the x-axis. So we're going to go from x, y to x -3y. And our function is going to just be -3x squared. For image number 3, again, I notice that the x values are the same as the pre-image, as the parent function, but all the y values have increased. And again, I'm looking at that 0 value is now a 7. And that's really the key that tells me, and I just double check it with the 1 and the 8, that this graph has moved up 7. So we're going from x, y to x, y plus 7. And our function is simply x squared plus 7. This is a review video, which means that you should be trying the problems on your own and then unpausing the video to check. So on page, here at homework answers, if you need them, they were in Drive last night. There it is. So if you need to see them, I don't know how great that is to see. Pause the video, check your homework from last night. And we're gonna work through these, but you should be pausing the video to try them on your own first. So on page 19, it says sketch a parent function for each graph type and write an example equation next to each type. So I'm going to write the parent functions if I know them. For linear, it's just y equals mx plus b. Exponential growth, there's a horizontal asymptote. And that's going to be like y equals a times b to the x, but b has to be greater than 1. So something like y equals 2 to the x, that would work. Exponential decay. Can be, again, y equals a times b to the x, but here b needs to be between 0 and 1, so something like 1/2 to the x. Polynomial could be it could be a parabola, it could be a cubic. I'll just write a cubic, looks like this. That's cubic function. It could be like x cubed plus 2x. That would be a good example. Quadratic. y equals x squared, and that parent function is ax squared plus bx plus c. A rational function has two asymptotes, a horizontal and a vertical. Parent function looks like this. The points are at 1, 1, and -1, -1, if you're being really specific. And y equals 1 over x is our parent function. It's not scrolling real well. There it goes. Absolute value functions. Those are our functions. They look like a V because all the negative values down here of the line were reflected up to make positive. And its parent function is absolute value of x. Logarithmic. Okay, now the two that people confuse the most are logarithmic and radical. I'm going to do them together. Logarithmic graphs have that vertical asymptote. They have a point at 1, 0. And they come up and across. They are the inverse of an exponential. Versus a radical function has a point on the origin because the square root of 0 is 0. The square root of 1 is 1. The square root 1, 2, 3, 4 is 2. They come up, but they have a similar shape, so they're frequently confused. Make sure you know the key differences, that logs have a vertical asymptote and run against it. Radicals have a point at 0, 0. Sine function starts at 0. Ooh, that is not so pretty. Cosine starts at 1. Remember, sine is an odd function. It has 180-degree rotational symmetry. Cosine is an even function. It is reflected over the x-axis. Tangent has a point at 0, 0 with vertical asymptotes at pi over 2 and negative pi over 2. And then this pattern repeats. That's not the most beautiful drawing. Good thing it's not art class. And those are the parent functions we have learned thus far. Okay. Again, you should be pausing the video for page 20. You have pages 20 and 21. These 8 functions match the 8 graphs on 20 and 21. It is your job to match the equations and write a sentence. The graph looks like blank, but blank. My suggestion is you pause the video and then I'm going to explain the answers to these 8. Okay, so for letter A is the absolute value of tangent. And the way I figured that out was I kind of noticed I have vertical asymptotes here. It looks like pi over 2, like 3, about 1.5. I see these vertical asymptotes, and it would switch to like a brighter color. It looks like these green pieces flipped over. So my sentence is the graph looks like tangent, but the absolute value reflects every point below the x-axis to above the x-axis. I might also say the graph looks like tangent because I can see the vertical asymptotes. But again, every negative y value is reflected. All right. So for letter B, I knew there was a sine or a cosine involved. And I see that there is a midline here that appears to be linear. I didn't quite go through the middle. And so I looked up here to see which ones had a midline. This one's got a midline of negative x squared. This one's got a midline of x squared. This one's got the midline of plus 3x. And that's why I made a decision to pick that equation to match with letter B, 5 cosine x plus 3, because the graph looks like cosine, but the midline is a linear equation. The slope of 3 is a bonus. I don't know that I would have noticed that had I not seen the equation of the line. All right, for letter C, this one was not so bad. It looked like a parabola. It has no negative y value, so I knew it was the absolute value of x squared plus minus 5 in my sentences. The graph looks like a parabola, but the absolute value reflects every point below the x-axis to above the x-axis. Okay, so again, just like letter B, I looked at letter D and I see it must be some kind of sine or cosine, but the midline looks like an upside down parabola, hence the minus x squared. So the midline looks like cosine, or sorry, the graph looks like cosine, but the midline is a reflected parabola. For letter E, that one was a little odd. I'm like, because that just kind of looks like a sine or a cosine. So I kind of was like, well, this one I used, this one I used. It's obviously not tangent plus. I used that one. These four I used. And I looked at what was left. Well, I knew that F was a sine or a cosine with a midline that's a parabola. So I knew that 2 sine 8x plus x squared went to letter F. So I looked at what was left. Here, this is an amplitude that's an exponential growth. This is an amplitude that's x squared. So I was like, this kind of makes sense. If you think about it, cosine x minus 5, and then because minus 5 would bring the whole graph below the x-axis, now all the points are above the x-axis. That's what made me pick the absolute value of cosine x minus 5 for letter E. Again, letter F, I knew it's got that midline is a parabola, so that was not so bad. And now I have these two left that have strange amplitudes. So the question is, which one has an amplitude of x squared and which one has an amplitude of 2 to the x? And you can see G, the amplitude is a growth function. And H, the amplitude looks like a parabola. And that literally is what I wrote for my sentences. Okay, so on page 22, again, you should be pausing the video. It is your job to state two function types that combine to make the graph and figure out what operation is used and what made you come to that conclusion. Please be very careful for sine and cosine. At this point, you should pause the video and then unpause it when you're ready. Okay, for function type 1, obviously I see this as some kind of quadratic function because I see a parabola. So the function type is not parabola, the function type is quadratic. Now the second function type, it's either sine or cosine. So I'm going to look here at 0, and I see it starts at a maximum. So I'm going to say function 2 is a cosine function. And because I see the quadratic is the midline, I'm going to say it's addition. And the reason, I'm going to say the graph looks like a cosine but has a midline that is a quadratic. Oops. The shape of the midline is a parabola. Okay, so for number 2, again, I've got some kind of sine or cosine, and this one's going to be really hard to see. I'm not sure. I might say it's a cosine. It kind of looks like it's starting at the top. I would probably accept sine for that one because it is really, really hard to see. Again, I also see there is some kind of parabola going on here. So I'm going to say the second type is quadratic. The operation between them is going to be multiplication. And my choice is that the graph looks like a cosine, but its amplitude is growing with a quadratic pattern. To study for your quiz on Monday, I would go back and really make sure you're solid. Pages 5 and 6 we did in class, writing geometric and function notation when given a pre-image and different images. You had homework that night on 7 and 8. So those are probably the pages to study. Those are definitely the pages to study for that topic. And then honestly, I would just, for the function, make sure you know all the functions, function families. Make sure we know the shape and parent function, proper name. And then in terms of combining the equations, I would use the review for combining equations. So that was on, the ones we did, the spinning high dive, the periodic bump, all that good stuff. I mean, you could also look at pages 16 and 17. The homework we did that night, that was a good assignment. But really, if you are solid on this review, again, 19 to 22, you should be in great shape for Monday.